Look around you. Everything you see, everything you touch feels solid, reliable, and predictable. When you drop a coffee cup, it shatters on the floor. When you look up at the night sky, the stars seem to trace eternal, majestic paths across the dark canvas. For centuries, we believed that if we just look closely enough, if we just built powerful enough telescopes and microscopes, we would finally see the absolute truth of the cosmos. But I am here to tell you that the universe has been hiding something from us. Throughout my career as a physicist, I spent decades wrestling with the most beautiful and terrifying ideas known to humanity. We have mapped the birth of galaxies. We have peered into the chaotic, buzzing heart of atoms. We have even captured the shadows of black holes. Yet, the deeper we go, the more we realize that our two greatest triumphs of science refuse to speak to one another. The smooth, curving space described by Albert Einstein and the frantic, jittery world of quantum mechanics are completely incompatible. They're like two fundamentally different languages describing the exact same reality. This contradiction keeps me and my colleagues awake at night. It suggests that there is a missing piece to the puzzle. There is one final secret hiding in the microscopic fabric of reality, a foundational truth that holds the universe together. Today, we are going on a journey to the very edge of human understanding to uncover this hidden architecture. And if you want to pull back the curtain on reality and join me in exploring the deepest mysteries of space and time, make sure you are subscribed. Now, let us step into the unknown. Imagine for a moment a beautifully crafted antique grandfather clock. You have probably seen one, heard its deep rhythmic ticking. If you open its heavy wooden door and look inside, you see a masterclass in predictability. Brass gears turning, weight slowly descending, a pendulum swinging back and forth with flawless precision. Every single movement is directly caused by the movement that came immediately before it. For nearly 300 years, this was exactly how we viewed the entire universe. When Isaac Newton looked up at the moon, he realized that the very same invisible force pulling an apple to the ground was also keeping the moon tethered in its orbit. He gave us a universe that was a massive, perfectly predictable machine. In this classical Newtonian world, space was just an empty box. It was a rigid, unchanging container where events happened. Time was an absolute cosmic metronome, ticking away at the exact same rate for everyone, everywhere. It did not matter if you were sitting comfortably in your living room or flying across the galaxy at unimaginable speeds. 1 second for you was exactly 1 second for me. It was common sense. It was intuitive. It felt completely right. But as we moved into the 20th century, our instruments grew sharper. We began to notice tiny cracks in this perfect clockwork. The most glaring problem involved the speed of light. Light travels at almost 300,000 kilometers per second, but experiments began to show something truly bizarre. No matter how fast you moved toward a beam of light or how fast you ran away from it, the light always approached you at that exact same speed. That makes absolutely no sense in Newton's universe. If I am driving down the highway at 100 kilometers per hour and another car passes me at 120 kilometers per hour, to me, that car is only moving at 20 kilometers per hour. Speed is supposed to be relative, but light refused to follow the rules of the road. This is where I must introduce you to the profound genius of Albert Einstein. And Einstein realized that if the speed of light is always constant, no matter who is measuring it, then something else must be flexible. Something else must give way. That something was space and time. Einstein completely shattered the idea of the rigid container. He showed us that space and time are not separate entities. They are woven together into a single, highly flexible fabric. We call it space-time. I want you to imagine a tightly stretched trampoline. If you roll a small marble across it, the marble travels in a perfectly straight line. But now imagine placing a heavy bowling ball right in the center. The fabric sags, stretching and curving around the heavy weight. If you roll that marble again, its path will no longer be straight. It will curve inward, caught in the depression made by the bowling ball. Einstein told us that this is exactly what gravity is. The sun is like that heavy bowling ball, creating a massive, deep valley in the fabric of space-time. The Earth is like the marble rolling endlessly along the curved, invisible walls of that valley. Gravity is not a mysterious invisible rope pulling objects together. Gravity is simply the shape of the universe itself. This revelation is breathtaking. General relativity gives us a cosmos that is perfectly smooth, continuous, and elegant. It is a universe where everything flows beautifully from one moment to the next. Using Einstein's elegant math, we can calculate the exact trajectory of a distant planet, predict solar eclipses centuries in advance, and trace the history of the cosmos back billions of years. For decades, it seemed, we had finally found the ultimate truth. We thought we possessed the master key to reality. But as we were about to discover, we were profoundly wrong. And while Einstein was looking up, reshaping our understanding of the stars with his elegant curves of space and time, another group of brilliant minds was looking in the opposite direction. They were looking down, deep down, into the microscopic building blocks of matter itself, and what they found there threatened to tear apart everything we thought we knew about reality. Right. Imagine taking a microscope to that heavy bowling ball we placed on our cosmic trampoline. If you zoom in close enough, past the polished surface, down into the atoms, you might expect to find a miniature version of our solar system. You might picture orderly little electrons orbiting a central nucleus, perfectly predictable, following the exact same laws of physics that govern the planets. For a brief moment in history, this is exactly what we believed. But that comforting picture is completely wrong. When we cross the threshold into the microscopic realm, the rules of everyday common sense do not just bend, they disintegrate completely. Welcome to the deeply unsettling world of quantum mechanics. In this tiny world, certainty vanishes. It is replaced by a cosmic game of chance. In our everyday classical world, objects have definite properties, whether we look at them or not. If you park your car in the garage, it stays in the garage. But in the quantum world, a particle like an electron does not possess a precise, exact location until you measure it. Before you look, it does not actually exist in any single defined place. Instead, it exists as a hazy cloud of pure probability. It is a smear of potential, statistically existing in many different places all at once. It is only the act of looking, the physical interaction of measurement, that forces the universe to make a choice and lock the particle into a definite spot. Albert Einstein fundamentally hated this idea. He famously declared that God does not play dice with the universe. The idea that reality at its most foundational level is driven by random, unpredictable chance felt deeply wrong to a man who had just revealed the majestic, predictable clockwork of the cosmos. Yet, experiment after experiment over the last century has proven beyond a shadow of a doubt that the quantum world truly is this. Bizarre. But the mystery deepens even further when we look closely at the fabric of empty space itself. Remember Einstein's smooth, elegant trampoline? It is a continuous, beautiful surface where everything glides gracefully. But if we were to zoom in on that very same fabric, down to the absolute smallest scales imaginable, that smooth elegance completely disappears. At the quantum level, space and time are boiling. It is a microscopic storm of unimaginable violence. The physicist John Wheeler called it quantum foam. Down in this microscopic basement of reality, even in a vacuum where absolutely nothing exists, phantom particles are constantly bursting into existence, borrowing energy from nothingness, and then violently annihilating each other in fractions of a microsecond. The microscopic arena of reality is frantic, jittery, and relentlessly chaotic. So here is the terrifying paradox that we are faced with today. We have two wildly successful frameworks for understanding our universe. General relativity gives us the massive, heavy things wrapped in a smooth, predictably curving geometry. Quantum mechanics gives us the tiny, light things governed by chaotic, jittery probability. Both theories have been tested and proven correct to astonishing degrees of precision. For most of human existence, this split personality of the universe goes unnoticed. You do not need quantum mechanics to predict the sweeping path of a comet, and you certainly do not need the theory of gravity to understand how a computer microchip works. But what happens when the universe forces these two vastly different worlds to meet? What happens when you have something incredibly heavy, which requires gravity, but incredibly small, which requires quantum mechanics? The universe actually creates these environments. We see this at the very center of a black hole, where the immense mass of an entire star is crushed down to a microscopic point. We also see it at the very beginning of time itself, the moment of the Big Bang, when the entire observable universe was compressed into a speck smaller than an atom. When we try to apply both sets of rules to these extreme places at the same time, our mathematics completely shatters. The equations literally break down, spitting out infinities and absolute nonsense. The universe is screaming at us that our understanding is fractured. There must be a deeper truth waiting to be found. I told you that our equations spit out absolute nonsense when we try to look at the center of a black hole or the very spark of the Big Bang. But I want you to truly understand why this happens. This is the heart of the paradox. Listen closely, because understanding this conflict changes the way you look at everything around you. Imagine you are flying in a commercial airliner, cruising 30,000 feet above the Pacific Ocean. If you look out the window, the water below looks like a perfectly smooth, unmoving sheet of blue glass. From this high up, you can see the gentle, predictable curve of the Earth. You can easily calculate the massive, slow movement of the tides pulled by the moon. This is the universe according to Albert Einstein in general relativity. It is the mathematics of the smooth, the heavy, and the macroscopic. It is a beautiful, predictable picture. But now I want you to jump out of that plane, fall all the way down until you are hovering just a few inches above the water during a violent hurricane. The smooth blue glass is gone. Instead, it is pure chaos. Crashing waves, violently bursting bubbles, swirling, unpredictable foam. There is absolutely no smoothness here. This is the quantum world. The paradox we face is that we are trying to use the mathematics of the smooth, high-altitude tides to calculate the exact shape and pop of a single microscopic bubble in that raging storm. It simply does not work. The rules are entirely incompatible. Let me show you exactly where the breakdown happens. In the quantum world, we understand that the forces of nature are communicated by tiny messenger particles. The force of electromagnetism, the light shining from your screen right now, is carried by a particle called a photon. So logically, we assume that the force of gravity must also have a tiny messenger particle. We call it the graviton. The problem arises when we try to bring this proposed graviton down into that microscopic storm, the quantum foam I described earlier. When we try to calculate how gravitons interact with each other in that frantically jittery environment, the mathematics literally explodes. Usually, when physicists do calculations, we get sensible, measurable answers. We get numbers like 2 or 50 or 0.008. But when we try to calculate the quantum behavior of gravity, the answer that comes out of the equations is infinity. And it is not just one infinity. We get an endless stream of infinities piling up on top of one another. In the world of theoretical physics, when your math gives you infinity, it is nature's way of slapping you across the face. It is the universe telling you that you are fundamentally misunderstanding what is going on. You have pushed your theory past its breaking point. This mathematical disaster happens at a very specific, incredibly tiny scale. It is a distance so unimaginably small that it makes a single atom look like an entire galaxy. We call it the Planck length. It is 0.0 followed by 33 more zeros and then a 1 of a meter. At this precise microscopic scale, the smooth fabric of Einstein's space and time completely rips apart. Gravity and quantum mechanics collide, and reality as we know it ceases to make sense. This catastrophic paradox forces us to confront a terrifying possibility. The space and time you and I experience right now, the very stage on which our entire lives play out, might not be a fundamental property of the universe. Think about a solid wooden table. It feels completely solid, but we know it is actually made of billions of microscopic atoms with empty space between them. The solidity is just an illusion, created by viewing it from far away. What if space and time are exactly the same? If space can bend under the weight of a star, if it can rip apart into a quantum storm at the Planck length, then space and time cannot be the bottom layer of reality. They must be made of something else, something deeper. We have spent centuries assuming that space is just the empty background of the universe. But if space is constructed of invisible microscopic pieces, what are those pieces? What is the hidden machinery operating below the basement of reality? The answer to that question will completely shatter your perception of existence. I told you that our equations blow up into impossible infinities when gravity meets the quantum world. But why? The problem, I realized along with many of my colleagues, stems from a deeply held assumption we have made for thousands of years. We have always assumed that the fundamental ingredients of reality are tiny, zero-dimensional dots. We picture electrons, quarks, and even the hypothetical graviton as infinitely small points of matter. But think about what happens when two infinitely small points collide in a turbulent quantum storm. Because they have absolute zero size, they can get infinitely close to one another. The force of gravity between them spikes so violently that the mathematics simply collapses. You cannot calculate the gravity between two dots that occupy the exact same invisible, infinitely small location. To fix this, we have to completely change our picture of the microscopic world. This is the moment I need you to abandon your everyday common sense and follow me into the absolute bleeding edge of theoretical physics. What if the smallest building blocks of the universe are not dots at all? What if, when we look deep inside an electron, deep inside a quark, we do not find a tiny hard sphere, but a microscopic vibrating filament of energy? We call this string theory, and it has been the central focus of my life's work. I want you to imagine a beautifully crafted cello. When you pluck a string on that cello, it vibrates in a specific pattern, producing a specific musical note. Pluck it differently, and you get a different note. The strings themselves are made of the exact same material, but their vibrational patterns create all the rich, complex music we hear. String theory suggests that the universe operates in the exact same way. If a microscopic string of pure energy vibrates in one specific pattern, it produces the mass and electric charge of an electron. If it vibrates in a different pattern, it manifests as a quark. And crucially, if it vibrates in yet another specific pattern, it produces the graviton, the elusive messenger particle of gravity. Suddenly, the entire universe is no longer a chaotic collection of random dots. It is a cosmic symphony. Everything you see, everything you are, is composed of these unimaginably tiny strings playing their quiet, eternal music. But here's the brilliant part. Here's how string theory solves our impossible paradox. Because strings are not infinitely small dots, but tiny loops or strands with actual physical length. They can never get infinitely close to one another. When two strings interact, they merge smoothly, smearing out the interaction over space and time. The sharp, violent collisions that plagued our old equations are instantly gone. The mathematical infinities vanish for the first time. The jittery quantum world and Einstein's smooth gravity are brought together in perfect, elegant harmony. It feels like a miracle, but the universe does not give away its final secrets for free. To accept string theory, we have to pay a price that will literally break your brain. And when we first put these vibrating strings into our equations, the math completely refused to work. The strings could not vibrate in the complex ways we needed them to. The only way to fix the mathematics, the absolute only way this beautiful cosmic symphony can exist, is if our universe has more dimensions than the ones we can see. We are intimately familiar with three dimensions of space, left and right, up and down, back and forth. and we know one dimension of time. But string theory demands that there are extra dimensions of space. In the most rigorous versions of the math, there must be 10 or even 11 dimensions weaving the fabric of reality. You are probably thinking, where are they? If there are 6 or 7 extra directions I can move in, why can I not see them? I want you to imagine looking at a long garden hose stretched across a large lawn from a helicopter hovering high above. From that altitude, the hose looks like a simple one-dimensional line. It only has length, but if you land the helicopter, walk over it, and look closely, you see that the hose also has a circular dimension wrapped around it. A tiny ant could walk along the length of the hose, but it could also walk in circles around its girth. We believe these extra dimensions are exactly like the circular part of the hose. They are wrapped up, curled so tightly at the microscopic Planck length that we simply cannot see them. But they are there, hiding in plain sight at every single point in space. They form the hidden shape of reality, guiding the vibrations of the strings and whispering the laws of physics into existence. You thought the universe was just what you could touch and see, but the truth is far more alien. Yet, as strange as extra dimensions are, they are leading us to a hard truth about reality that is even more terrifying to work. Except, I told you that extra dimensions are curled up all around us, hiding at every single point in space. But you might naturally wonder, what does a microscopic invisible dimension actually do? Why does its existence matter to you and me? I want you to think about a beautiful, complex musical instrument, like a French horn. When a musician blows air into the mouthpiece, that air is forced to travel through a labyrinth of curled and twisted brass tubes. The exact physical shape of those tubes restricts and guides the airflow, determining the exact musical notes that can be played. If you take a heavy hammer and dent the brass, changing its internal shape even slightly, the notes will instantly change. The instrument will sound completely different. In string theory, the curled up extra dimensions are the brass tubes of the universe. The vibrating strings of energy are the air flowing through them, the exact microscopic geometry of those hidden dimensions dictates exactly how the strings are allowed to vibrate. And remember, those vibrations determine everything. They determine the mass of a quark, the charge of an electron, the strength of gravity, and the speed of light. The invisible shape of space literally creates the laws of physics that govern our reality. When my colleagues and I first realized this, we were ecstatic. We thought we were on the verge of the ultimate triumph of physics. We believed that if we could just solve the equations, we would find one unique mathematical shape for those extra dimensions, one perfect geometry that produces exactly the universe we see around us. With our specific electrons, our specific gravity, and our specific stars, we spent years searching for this mathematical holy grail. We wanted to prove that the universe had to be this way, that our reality was the only mathematically possible reality. But here's the hard truth. We were incredibly naive. When the mathematics finally settled, it did not give us one perfect, unique shape. It gave us a sprawling, unimaginable landscape of possibilities. The equations revealed that those extra dimensions can be folded and twisted into an incredibly vast number of different geometries. How vast? Imagine the number 10. Now put 500 zeros after it. That is a number so incomprehensibly massive that if you were to write a single zero on every single atom in the observable universe, you would run out of atoms long before you finish writing the number. That is how many different ways the fabric of reality can fold. And this is where the truth becomes terrifying, because each one of those shapes produces a universe with entirely different laws of physics. In one shape, gravity might be billions of times stronger, causing any newly born universe to instantly collapse back in on itself into a microscopic black hole. In another shape, the forces holding matter together might be entirely absent, resulting in a universe filled with nothing but a thin, freezing mist of chaotic particles where atoms can never form. In almost all of these 10 to the power of 500 possibilities, the resulting universe is a sterile, hostile void. For a long time, physicists viewed this landscape of possibilities as a massive failure of string theory. We wanted a theory of everything, not a theory of absolutely anything. But then we looked back up at the cosmos. We combined this idea with our best understanding of the Big Bang, a theory called cosmic inflation. Inflation tells us that the rapid expansion of space at the beginning of time was not a single isolated event. It is a process that is constantly happening forever. The fabric of reality is like a wildly boiling pot of water. Every single popping bubble in that pot is an entirely new universe expanding into existence. When you put these two ideas together, the hard truth of our existence is finally revealed. We do not live in a single solitary universe. We live in a multiverse, an endless, eternally boiling ocean of realities. Every time a new bubble universe is born, the extra dimensions inside it freeze into one of those 10 to the power 500 different shapes. You might ask, why do we live in this specific bubble? Why do we live in the one universe where the extra dimensions are shaped perfectly to allow for atoms, stars, planets, and human life? The answer is as humbling as it is beautiful. We live here because we could not possibly survive anywhere else. We are just a statistical accident in a cosmic lottery of unimaginable scale. We are finally forced to accept that our entire universe is nothing more than a tiny, fragile oasis in an infinite desert of dead realities. Imagine walking alone on a vast, endless beach at night. The sand stretches out for millions of miles in every direction. Each individual grain of sand beneath your feet represents an entire universe. If you were to pick up almost any grain at random and look inside, you would find absolute darkness. You would find laws of physics so twisted and chaotic that nothing meaningful could ever take shape. No light, no warmth, no chemistry, no life, just a sterile, frozen void. But then, against all mathematical odds, you reach down and pick up one specific grain. Inside this one, gravity is perfectly balanced. Electromagnetism hums with the exact right energy. Stars ignite, cooking up heavy elements in their fiery cores. Planets form, water flows, and eventually, incredibly complex arrangements of molecules begin to look back up at the sky. That single, impossible grain of sand is our universe. For a long time, the history of human discovery has been a story of demotion. Nicolaus Copernicus taught us that we are not at the center of the solar system. Edmund Hubble showed us that our galaxy is just one of hundreds of billions drifting through the dark. And now, the combined power of string theory and cosmic inflation has delivered the ultimate humbling blow. Our entire universe, everything we have ever observed or will ever observe, is just one microscopic statistical anomaly in a violently boiling ocean of infinite realities. We have been completely removed from the center of existence. It is incredibly easy to look at this vast, sprawling multiverse and feel entirely meaningless. If there are infinite universes and infinite versions of reality playing out forever, what does our fleeting existence matter? But I want you to look at it from a completely different perspective. Listen closely. The reality you experience every day hides a terrifying and fascinating secret, but it is also overwhelmingly beautiful. For almost 14 billion years, the matter in our universe was entirely unconscious. It was just expanding gas, crashing rocks, and burning nuclear fires. But then, on one tiny rocky world orbiting an entirely average star, the vibrating strings of energy arranged themselves into a pattern so astonishingly complex that they woke up. They became you, and they became me. We are not separate from the universe. We are the universe. We are a localized piece of the cosmos that has developed the ability to think, to reason, and to ask questions about its own origins. We are the universe experiencing itself. Think about the sheer impossibility of what we are doing right now. We are a species of primates that evolved to hunt and gather on the African savanna, yet using nothing but the gray matter in our skulls and the mathematics we invented, we have managed to peer through the physical illusions of space and time. We have reached down into the microscopic quantum storm. We have visualized the hidden, curled up dimensions of reality, and we have deduced the existence of an infinite multiverse that we can never even physically see. That does not make us meaningless. That makes us the most profound, miraculous phenomenon in the entire landscape of existence. We are the fleeting, beautiful moment when the infinite multiverse finally opens its eyes and tries to understand itself. Uncovering these deep truths is not easy. It takes decades of rigorous mathematics, endless debates, and a relentless refusal to accept comfortable illusions, bringing these complex ideas to you. Translating the bleeding edge of theoretical physics into a journey we can take together is my absolute passion. But mapping the multiverse requires immense time, resources, and dedication. If this journey has shifted your perspective to